Hi friends, welcome to our YouTube channel. Today we have to discuss about binary search program with one example problem. First, I am writing the logic of the binary search program here. After that, apply this logic to the given example problem. Okay. First, we have to write the logic. So the logic begins here. First, low is equal to 0, semicolon. So index 0 can be assigned to the variable low. Next, high is equal to n minus 1. N minus 1 index can be assigned to the variable high. Next, while low less than or equal to high. If low value is less than or equal to high, then the body of the while loop is executed. In the body of the while loop, first we have to calculate the mid value. So mid is equal to low plus high by 2. So low plus high by 2. After calculating the mid value is compared with the desired key element you want to search in the given array. If key value is equal to A of mid value. Okay. If key value is equal to A of mid value, then so printf successful search. Printf successful search. Because our key element is found in the given array. Okay. Next one is printf key element found at %d position. Key element found at %d position. Okay. So double quotes and comma mid value. Key element is found at mid value. Okay. Next one, after that, break. Next, suppose if the key value is not equal to A of mid value, then we can go for else if. Else if key value is greater than A of mid value. If key value is greater than the A of mid value, then low is equal to mid plus 1. Low is equal to mid plus 1. Suppose else. Else means if key value is less than A of mid, then high is equal to mid minus 1. High is equal to mid minus 1. Okay. Then while close, then the program is closed. Okay. If the while condition is false, then the control goes to the next statement after the while loop. There are no statements are there, then the program is terminated. Okay. So this is the simple logic of binary search program. Index 0 can be assigned to the low value. N minus 1, where n is the size of the array. So n minus 1 value can be, n minus 1 index can be assigned to the variable high, while low less than or equal to high. Here we are comparing only index values. So 0 less than or equal to n minus 1. Low index value is 0, high index value is n minus 1. While 0 less than or equal to high, if this condition is true, then the statements within the body of the while loop are executed. First, if the condition is true, then the control goes to the body of the while loop. First, we have to calculate the mid value. Mid is equal to low plus high by 2. So, low is index 0, high is n minus 1 index. So, after calculating the mid value, first we have to compare the key element with mid value. So, okay, key equal to A of mid value. If the key value is equal to mid value, then we can say that printf successful search. That means our key element is present in the given array. Next, printf key element is found at %d position. So key element is found at mid position. Okay. So once these two statements are executed, then break. So this statement terminates the program control from the given while loop. So then the program control send it to this point. Okay. Next one. Suppose if the key value equal to A of mid, this condition is false, then the control goes to the next else if. Here else if key greater than A of mid value. If key value is greater than the A of mid value, so then if this condition is true, then ignore the first left sub array. By considering the second sub array. So low is equal to mid plus 1. After ignoring the first left sub array, okay, we are considering the right sub array. Okay, so here if this condition is true, we are ignoring the left sub array and we are considering the right sub array. Suppose if the key value is greater than A of mid is false, then go to the else. Here we one more condition is there here. So key less than A of mid. That means key element is found at first sub array and ignoring the second sub array. Okay, we are considering the left sub array and ignoring the right sub array. So by considering this statement, high is equal to mid minus 1. So by using this statement, we can say that ignoring the right sub array and taking the left sub array. Okay, here the mid value can divide the total array into two sub arrays. Okay, before the mid, left sub array, after the mid, right sub array. Okay, if this condition is true, we are considering only right sub array by ignoring the left sub array. Suppose here if this condition is false, then we can go to this part. So this means this statement means ignoring the right sub array and only considering the left sub array. Okay, so at a time we can ignore one sub array and considering only another sub array. So by using the binary search, we are always considering only half sub array and ignoring the remaining sub array. So because of that reason, searching can be done very fastly when compared to the linear search. Okay, so this is the explanation of the binary search program logic. Now this logic can be applied to this example problem. Apply the binary search logic to search for a key element 58 in the following array elements with array size 10. Here n value is equal to 10. That means array size is equal to 10. Okay. Next one. So these are the given elements. The index, array index starts with 0 and ends with n minus 1. N value 10, that means n minus 1 is 9. 10 minus 1, that is 9. Okay. Next one. First, index 0 can be taken as low value. Here this is index 0 that can be taken as low value. N minus 1 index, n value 10, 10 minus 1, that is 9. Index 9 can be taken as high. Okay, so low value is equal to 0, high value is equal to n minus 1. Next, while low less than or equal to high, that means while low less than or equal to high, low value is 0, index 0, less than or equal to high value is 9. 0 less than or equal to 9. So condition true. If this condition is true, then calculate the mid value. So mid is equal to low plus high by 2. Low value 0, high value 9. 0 plus 9 by 2. Actually, we are getting 4.5. So we are always taking the floor value. So 4.5 floor value is equal to 4. Okay. So now this mid value is equal to 4. That means index 4. So this is the mid value. So this mid value divides the given array into two sub arrays. Okay. So before the mid value, that is called as left sub array. After the mid value, that can be called as right sub array. Okay. That means we are getting this one. So 10, 12, 15, 18, 24, 32, 45, 58, 65, 75. Okay, so this is the mid value. Okay, so this mid value divides the given array into two sub arrays. Before the mid value, that can be called as left sub array. Left sub array. After the mid value, then that can be called as right sub array. So mid value divides the given array into two sub arrays. Before the mid, that can be called as the left sub array. After the mid, that can be called as right sub array. Okay, next one. Next step is if key equal to a of mid. What is key value? Key value is 58. Okay, so if key value equal to a of mid. Okay, so here what is key value? Key value is 58. What is a of mid? Mid value is 4. That means a of 4. A of 4 value is 24. 58 equal to 24. That is false condition. Okay. Next, if this condition is false, then the control goes to the next else if. Okay. Here I am considering this one. Else if key greater than a of mid. Key value is 58 greater than a of mid. That means a of mid is the value is 4. A of 4, that is 24. 58 greater than 24. Condition is true. If this condition is true, then we can go to the low is equal to mid plus 1. Mid value 4, 4 plus 1, that is equal to 5. Okay, low is equal to 5. That means after calculating the mid value, the given array is divided into two sub arrays. Before the mid, that can be called as a left sub array. After the mid, that can be called as right sub array. Okay, after that, key value is compared with a of mid value. If this condition is a false, then go to the else if key value is a of greater than a of mid value, so low is equal to mid plus 1. That means if key value is greater than a of mid value, okay, our key element is 58, mid element is 24. 58 is compared with the 24, so 58 is greater than 24. At that time, our key element is present in the right sub array. Hence, we can say that we are ignoring the left sub array. Okay, if the key value is greater than a of mid value, that means our key element is found in the right sub array, then we have to ignore the left sub array. So key element is 58, mid element is 24, 58 is compared with the 24, condition true. We are considering only right sub array by ignoring the left sub array. Okay, so considering right sub array, by ignoring left sub array, So after ignoring the left sub array, okay, only we are considering the right sub array. So the right sub array contains 32, 45, 58, 65 and 75. So what are the index values? Index values are same. 32 index is 5, 45 index is 6, 58 index is 7, 65 index is 8 and 75 index is 9. Okay. Again we are checking the condition. Here what is low value? Now this is low value and this is high value. Okay. Now low value is here. I am writing here. Okay. Now low less than or equal to high. So while low value is nothing but 5. 5 less than or equal to 9. So that is condition true. If this condition is true, then body of the while loop is executed. First we have to calculate the mid value. So mid is equal to 5 plus 9 by 2. 5 plus 9 by 2, that is 14 by 2, that is 7. So mid value is 7. Okay. Again, the mid value can be divided before the mid value. So this can be taken as left sub array. After the mid value, this can be called as right sub array. The mid value can divide the given array into two sub arrays. Before the mid value, that can be called as a left sub array. It contains only two elements, 32 and 45. After the mid value, only two elements are there. That can be called as a right sub array. It contains 8 and 9. Okay, so the mid value can divide the given array into two sub arrays, left sub array and right sub array. After calculating the mid value, next we have execute the if statement. Key equal to a of mid. So key equal to a of mid value. Okay. So what is key value here? Key value is 58. A of mid, that means a of 7. Mid value is 7. A of 7 element is 58. So 58 equal to 58. So condition true. If this condition is true, then what is the statement we are executing? So printf search is successful. So our key element is equal to A of mid value. So if this condition is true, then the statements within the if block are executed. So successful search, because our key element is found in the given array. So search is successful. Search is successful. Next statement is key element. What is the key element? 58 is found at which position? Mid position. Mid position is 7th position. Is found at 7th position. Okay. So search is successful and key element 58 is found at 7th position. This statement is executed. After that, break. So by using the break statement, the program control can be terminated from the current while loop. Then the program control can be transferred to after the while loop. There are no statements are there. Then the program is terminated. So this is the procedure we have to follow for searching a key element among the given array elements. Okay. Here the binary search is efficient because in the case of binary search, okay, we are ignoring the half sub array by considering the half sub array. At a time, half sub array is ignored and half sub array is considered after calculating the mid value. Mid value divide the given list into two sub arrays. Okay. Before the mid value, that can be taken as left sub array. After the mid value, that can be taken as right sub array. Now key element is compared with the mid element. Suppose if the key element equal to A of mid element, then search is successful. Next, key element is found at %d position. After that, break statement is executed. Suppose key element is not found at the mid position. Okay. Key element is compared with the mid value. If key element is less than the mid value, we are considering the left sub array by ignoring the right sub array. If key element is greater than the mid value, we are ignoring the left sub array by considering the right sub array. Again, we are calculating the we are newly calculate the low value and high value. Then again we are checking the condition low less than or equal to high. Then we are calculating the mid value. Once we are calculating the mid value divides the given array into two sub arrays. If the key element is greater than the mid element, then considering the right sub array by ignoring the left sub array. If key element is less than the mid value, considering the left sub array by ignoring the right sub array. This procedure is continued until our key element is found. Okay. So binary search is efficient because at a time half sub array can be ignored and half sub array can be considered. Number of comparisons are less when compared to the linear search. Hence we can say that the binary search can be done very fastly. What is the time complexity of binary search? Order of log n. So log n can be occurred in the time complexity when the given list is divided into two sub arrays. Okay. At that time, log n is occurred in the time complexity. Here, the given array can be divided into two sub arrays. Then we are getting the log n. So, in the worst case and average case, the time complexity of binary search is order of log n. In the best case, the time complexity is order of 1. So this case occurred when the key element is found at the mid position. Okay, so then only within one comparison our key element is found only by calculating the mid value. So that case is called as best case. Within one comparison our key element is found, therefore the time complexity is order of 1. Worst case and average case, the time complexity of binary search is big O of log n or order of log n. So this is the description about the binary search program. Now we have to see the implementation of binary search program that are already discussed in previously. So this is the binary search program. So whatever I am discussing the logic previously with one example problem, the same logic that we are written in the binary search program. Okay, so I am explaining one time the logic of binary search program. Here the available array size is A of 50. Okay, this is the available array size. From the available array size, we have to take only the required array size by reading the n value from the keyboard. Okay, next one. After that, we are entering the array elements from the keyboard by using scanf function. Next, after that, whatever the elements that are read from the keyboard, that elements are printed by using this statement. Next, after that, enter the key element you want to search. That key element is read from the keyboard by using scanf function. Okay. Next one, low is equal to 0, high is equal to n minus 1, while low less than or equal to high. First we have to calculate the mid value. Once we are calculating the mid value, key value is compared with the mid value. If key value equal to A of mid value, we can say that search is successful. Key element is found at mid position. After that, break statement. Okay, if this break statement is encountered, the program control can be transferred outside the while loop. Okay, next statement after the while loop. So then the program control goes to this statement. Okay, if low greater than high, we can say that printf unsuccessful search key element percentage %d is not found in the array. Okay, suppose if the key element is greater than A of mid value, we can say that low is equal to mid plus 1. Suppose if key value is less than A of mid value, we can say that high is equal to mid minus 1. So high value is updated to mid minus 1 if key less than A of mid. Suppose if key greater than A of mid, low value is updated, low is equal to mid plus 1. Suppose if key value is equal to A of mid value, then we can say that search is successful, key element percentage %d is found at percentage %d position. After that, break statement is executed. Okay, so this entire body of the while loop is executed when low less than or equal to high. Suppose low less than or equal to high condition false, then the control goes to the next statement after the while loop. The next statement after the while loop is this one. If low greater than high, we can say that printf unsuccessful search. Next, printf key element percentage %d is not found in the given array. Okay, so this is the simple program
by simple binary search program. Okay, now we have to execute our binary search program. So Alt C, Alt C. So by using Alt C statement, we have to compile the program. So we are getting 0 errors and 0 warnings. Then press enter. After that, we are pressing Alt R. So we are running the program. Then they ask enter the required array size. The required array size I am taking 10. Okay, enter the array elements. We are entering 10 array elements from the keyboard, that are 10, 12, 15, 18, 24, 32, 45, 58, 65, 75. Next, the entered array elements are printed as it is. Enter the key element you want to search. Suppose I want to search the key element 58 in the given array. So search is successful. Key element is found at 7th position. Okay. So 0th position 10 is there. 1st position 12 is there. 2nd position 15 is there. 3rd position 18 is there. 4th position 24 is there. 5th position 32 is there. 6th position 45 is there. 7th position 58. Key element 58 is found at position 7. Okay, so search is successful. Now one more time we are executing the same program. So Alt C, compile the program, press enter, Alt R, run the program, then enter the required array size 10. The same elements I am given. So 10, 12, 15, 18, 24, 32, 45, 58, 65, 75. The same 10 elements are printed as it is. Enter the key element you want to search. Now I am giving 85. So 85 is not there in the given array. 85 key element is not there in the given array. So unsuccessful search, key element 85 is not found. Okay, so this is the implementation of binary search program that are already explained the logic. The same logic is implemented in this program. Then we are getting the output. So this is the binary search program in C language. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please click on the like button. If you like this video, please subscribe my YouTube channel DIVVELA Srinivasa Rao. Thank you for watching this video.